Hello, my name's McKenna Croft, and this is my test number 3 wrapper assignment. So for test 3, I chose problem 2 because it was the most difficult for me. So in problem 2, we're considering a charge Q moving with velocity V and a magnetic field B, and the force on the charge is equal to the force equal to the charge times the cross product of the vector and the magnetic field. So the first question says that the charge Q makes a displacement dr and a time dt, and we're using dr equals v dt to prove that the work done on the charge by the magnetic force times dr is 0. So first we're going to write out the force times dr formula, which is equal to the change in work, and then we know that the force is equal to Q times the cross product of V times B. So then we input that into the formula, and that gives us 0 because the cross product of the velocity times the magnetic field vector is perpendicular to the velocity. So in other words, the work done is 0. All right, so for the second question, we're given 2 loops of resistive wire that carry currents I1 and I2. And so we're trying to find if the loops attract or repel. So in this case, they would attract. The magnetic field due to I1 points out of the page at I2 on the left side. Therefore, F mag points to the left, and vice versa with F mag of I2 on I1, which points to the right. And this is because the magnitude of the magnetic field decreases with distance from current. Repulsive F mag on the outer sides of the loops is smaller than the attractive force. So the attractive force is greater. All right, so for part 3, it states that I1 loop is held fixed and I2 loop is not. The force causes I2 to accelerate, and at any moment in time, the center of mass of the whole loop must have a non-zero velocity. And then the total velocity of the electron in the I2 loop is equal to the drift velocity plus the center of the velocity of the center of mass. So the drift velocity constitutes the current I2, and so we're trying to derive a 4-term expression for the total work done on one electron in the I2 loop. So why are 2 of these terms 0? Is the other question we're going to answer. So the total work we know is equal to force times dr, and so you can use the same equation we used for part 1 of this question, and we can input our velocities and our magnetic field here. So we know that we have an electron, and we have the drift velocity and the center of mass velocity, and then we take the cross product of this velocity with our magnetic field, and then we multiply that by the velocity, which I just said was the drift velocity, plus the center of mass velocity, and that's the change, and then multiplied by the change of time. So our first term here is the drift velocity times the magnetic field times the velocity of the change in of time. And the second term, we're still using the drift velocity times the magnetic field, but this time we're using the velocity of the center of mass and the change of time for the velocity. And then finally, for our last terms, we are using the center of mass velocity and the drift velocity, and in contrast, the fourth term uses the center of mass velocity and for both parts of the equation. We know that 1 and 4 are 0 because of the repeated velocity vector, so that means the drift velocity times the magnetic field, which is perpendicular to the drift velocity, and also the velocity of the center of mass times the magnetic field is perpendicular to the velocity of the center of mass. Okay, so for our fourth question, we're finding how the two non-zero terms in the previous calculation, so that's going to be 2 and 3, are related to each other in magnitude and sign. So we're going to use that same work, the total work formula, and we're going to input our two terms. And we can see here that the two terms must be equal in magnitude and opposite in sign for the total work to be 0. So the final question asks, one of the two non-zero terms in part D can be interpreted as a which accelerates the mass of the wire of the I2 wire in part B. The other can be interpreted as a work which changes the drift speed of the electrons, which constitutes the current I2. So we're trying to find which term is which and why. So based on the terms we have listed here, which one applies to I2 and which one applies to I1. So, and it's actually which term applies to the drift speed versus the center of mass. So we know that the first term, which is the first term here, which is the drift velocity and the center of mass used for the velocity. So we're using the cross product of the drift velocity and the magnetic field to determine the work on the center of mass, because it's proportional to the displacement of the center of mass through dr of the center of mass is equal to the velocity of the center of mass, dt. And then finally, the last term, we're using basically just the opposite of this first equation here, where the center of mass is used in the velocity of the center of mass cross product with the magnetic field is multiplied by the drift velocity times the change in time. And this changes the drift speed because it's proportional to the displacement due to drift velocity. So in other words, the RD equals the drift velocity times the change in time. And that is the second problem.